In this session, we're going to explore equations of lines. There are three forms of equations that we care about. They are standard form, point-slope form, and slope-intercept form. Standard form is ax plus by equals c, and when an equation is written in standard form, we prefer to have no fractions. Note that x and y are on the same side. We prefer that a be positive. Point-slope form is y minus y1 is equal to m times the quantity of x minus x1. It's called point-slope form because the x1 and y1 are coordinates of a known point, and m is a known slope. Slope-intercept form is y equals mx plus b, and is so named because m is a slope and b gives the coordinate of the y-intercept, which is an ordered pair 0b. Point-slope form is generally the starting point when we are coming up with the equation of a line, and typically the answers are given in standard form or slope-intercept form depending on what's going to be done with it and the instructions given in the problem. It's fairly easy to convert between these two forms. Before we get started, let's take a look at point-slope form. If we consider the slope formula, which is m equals y2 minus y1 over x2 minus x1. Remember, this gives the slope between 2 points on a line, and if one of these has coordinates x1, y1, and the other has coordinates x2, y2, then this slope formula makes perfect sense. However, if instead of considering two specific points on the line, we consider a specific point and a generic point that has coordinates x, y, then the slope between xy and x1, y1 would be given by m equals y minus y1 divided by x minus x1. Now if I move the m to the right hand side and then clear the fraction by multiplying both sides by the common denominator of x minus x1, then on the left hand side it divides out. I end up with y minus y1 is equal to n times the quantity of x minus x1, which is point-slope form, and so we can see that this is simply a rearrangement of the slope formula. Let's get started with our first example. Find the equation of the line with a slope of m equals -4 and containing -2, 3. Well, we can use either point-slope form, y minus y1 is equal to m times x minus x1, or if we wanted to, we could simply use y equals mx plus b, considering we have a slope, an x, and a y, and we would just need to find b. I'll end up using both of these techniques, but not on the same problem. Let's start using point-slope form. Y minus y1, well 3 is y1, is equal to m is -4 times the quantity of x minus -2. We have to mind our negatives here. There's a minus built into the formula, and the coordinate is a negative number. First, dealing with the double negative, we have y minus 3 is equal to -4 times the quantity of x plus 2. Distributing the -4 gives us y minus 3 is equal to -4x minus 8. And finally, adding 3 to both sides gives us y equals -4x minus 5. If I wanted to check that this were correct, I would verify that I have the correct slope, -4, and I would want to make sure that -2, 3, when in place of x and y, actually yields a true statement. Now, if I was asked to give the answer in slope-intercept form, this would be it. If I was asked instead to give this in standard form, I would add the 4x to both sides, thereby getting x and y on the same side, and we would end up with 4x plus y is equal to negative 5. And again, this is dependent upon our purposes and our instructions. Either of these could be a correct answer to this problem. Next we have find the equation of the line that contains negative 2, 1, and 5, negative 2. Let's step back a minute though. In the previous example, we were given a slope and a point, and that was enough to use either point-slope form or slope-intercept form. Those are the two things that we need to come up with the equation of a line. Here I have 2 points, and I can find the slope between them easily enough and then use either of the points in the formulas. First we find the slope. The slope formula is m equals y2 minus y1 divided by x2 minus x1, and I'll select negative 2, 1 to be the y2 and x2, and 5, negative 2 to be y1 and x1. Using this order, we have m equals, in the numerator 1 minus negative 2, and in the denominator negative 2 minus 5. Again, we use negative 2, 1 as our x2 and y2. They were the first terms in the numerator and denominator, and 5, negative 2 as the second terms in the numerator and denominator. Well, simplifying gives m equals 1 plus 2 divided by negative 7, and so our slope is negative 3/7. Now we have a slope. We need to use a point. We can use either negative 2, 1 or 5, negative 2. I'm going to go with negative 2, 1 in this case. We could use point-slope form. Y minus y1 is equal to m times x minus x1. But I'm going to use slope-intercept form. Y equals mx plus b, just so you can see how we use it. In this case, since we're using negative 2, 1, y is 1, m is the negative 3/7 that we found, x is negative 2, and we can solve for b. So we've got 1 is equal to negative 3/7 times negative 2. Considering that negative 2 to have a denominator of 1, multiplying across the numerators gives us positive 6/7. And then plus b. Subtracting 6/7 from both sides, considering 1 as a fraction, 7/7, will give us 1/7 is equal to b. And now I can put this information together. I have the slope, negative 3/7. I have b as 1/7. And so y is equal to negative 3/7 x plus 1/7. This would be the answer in slope-intercept form. If I were asked for standard form, I would first add 3/7 x to both sides, getting x and y on the same side, and then multiply everything by 7 so that my final answer has no fractions. 3x plus 7y is equal to 1. And again, depending on context and the instructions, either of these could be the solution to the problem. Next we have find the equation of the line that contains negative 3, negative 1, and negative 3, 7. This is only slightly different than the previous example, and you'll see how in a minute. We first start by finding the slope. The slope formula is m equals y2 minus y1 divided by x2 minus x1. Letting negative 3, negative 1 represent x2 and y2. I'll put them first. Negative 1 minus 7 divided by negative 3 minus negative 3. In the numerator, we have negative 8. In the denominator, though, after dealing with the double negatives, we have 0. This is undefined. And you may recall a line that has an undefined slope is a vertical line. In this case, we have negative 3, 1 and negative 3, 7, and I see that in both cases x is equal to negative 3, and you may recall that a line that has an undefined slope has an equation x equals. This can't be put into slope-intercept form. The answer is x equals negative 3. In our next example, we're asked to find the equation of the line that passes through 3, 5 and is perpendicular to 2x minus y is equal to 8. Remember that the two things that we need to come up with the equation of the line are a slope and a point. I have the point, and I'll get the slope by solving 2x minus y equals 8 for y. I have negative y is equal to negative 2x plus 8. Multiplying through by a negative 1 gives me y equals 2x minus 8. And remember that since this is slope-intercept form, the coefficient of x, in this case 2, is the slope of the line. At this point we can identify the given slope, the one that we got from the line, is m is equal to 2. For a perpendicular slope, m sub perpendicular, we flip the number and we flip the sign. In other words, the product of the two slopes must be negative 1. Or two slopes must be negative reciprocals of each other. Now I have a slope that's perpendicular to the given line, m equals negative 1/2, and I have a point that was given, 3, 5, and in this case I'll use point slope form. Y minus y1 is equal to m times x minus x1. We have y minus 5 is equal to negative 1/2 x minus 3. Distributing on the right hand side, I get y minus 5 is equal to negative 1/2 x plus 3/2. That's a plus because we're multiplying a negative by a negative. And it might be easier to think of 5 as a fraction with a denominator of 2. So 5 with a denominator of 2, that's 10/2. So y minus 10/2 is equal to negative 1/2 x plus 3/2. Adding 10/2 to both sides gives me y is equal to negative 1/2 x plus 13/2. This answer is in slope-intercept form, and to give the answer in standard form, I'll add 1/2 x to both sides to get 1/2 x plus y is equal to 13/2, and then multiply by 2 to clear the fractions. X plus 2y is equal to 13. These are the two possible solutions to this problem. Now let's compare what we were given with what we found. We were given an equation of a line, 2x minus y equals 8, and we wanted an equation that was perpendicular to that and contained the point 3, 5. Solving 2x minus y equals 8 for y, we got y equals 2x minus 8. I've recorded that information down here. The given line is y equals 2x minus 8. Remember, our desired line was supposed to be perpendicular and contain the point 3, 5. I'm going to graph these two lines, y equals 2x minus 8 and y equals negative 1/2 x plus 13/2 for comparison. Here we have the line y equals 2x minus 8. Including this line y equals negative 1/2 x plus 13/2, we can see that it looks roughly perpendicular, so we have a visual verification that they look like what they're supposed to look like. And remember that the desired line was to contain the point 3, 5. Well, the desired line looks like it contains the point 3, 5. And so this is a visual verification of what we were to find, and it's not uncommon on an exam for me to ask you to graph the given line and the line that you found. Finally, we're asked to find the equation of the line that contains 2, 5 and is parallel to the line through 3, -8 and -1, 4. Again, the two things that we need are a point and a slope. I have a point. The line contains 2, 5. I need a slope. So using the slope formula, m equals y2 minus y1 over x2 minus x1, we get m equals 4 minus -8 divided by -1 minus 3. Dealing with the double negative in the numerator, we have m is equal to 12 divided by -4, which means that the slope is -3. Now in this case, we're asked for the line parallel to the line through the two given points. Parallel lines have the same slope. So we're going to use this m equals -3, and I'll use slope-intercept form. Y equals mx plus b. Fleshing this out using 2, 5, we have 5 is equal to the given slope, -3, times 2 plus b. So 5 is equal to -6 plus b, or b is equal to 11. Now I'm going to put b equals 11 and m equals -3 in place of m and b in the slope-intercept form of the line, and get y equals -3x plus 11. That's the line in slope-intercept form. The equation of the line in standard form is 3x plus y is equal to 11.